parts of our nervous system today. I'm going to be on the floor because I forgot my stand at home. So let's start out with drawing brain. Ooh, that's a big. And the brain stem. So the three systems or three branches of the nervous system they wanted to talk about. They wanted to talk about the somatic nervous system. Can't see that up there. So over here, somatic nervous system. And then the autonomic nervous system. The autonomic has two divisions. It has the parasympathetic, straight para, and the sympathetic, nervous system. So the somatic nervous system, it's composed of sensory fibers and motor fibers. These originate in the brain, they travel down the spinal cord, they come out in the spinal nerves, they go to muscles, mainly muscles, and then also you have the sensory coming back in, so any sensory organs, skin, you feel pain, you feel heat, that's your somatic nervous system. The autonomic nervous system is something that I want to talk a little bit more about today. Has the two divisions, like I said, the parasympathetic and the sympathetic divisions. The sympathetic division is going to, you've probably heard of this before, but it's your fight or flight division, and the parasympathetic is your rest and digest. So these all innervate the same thing. So we'll have like our heart up here and our lungs right here, right next to the heart. We'll move that a little bit further away. And our heart, and then we'll have our stomach and our intestines down here. Kind of a rough general drawing. They're going to innervate both sides. I'll label this side, so we're going to go to the brain here, and we're going to say this is our sympathetic side. And we can do the same on this side. We'll draw another brain really quick. Another brain. Spinal cord coming down. And then on this one, I'm going to draw sympathetic chain ganglion. This is just right next to the spinal cord. Another one on this side, even though there would be one on both sides of it. The sympathetic chain, one thing that it innervates completely by itself, it will come over here and it will do skin, so like erector papillae, skin, sweat glands. These are generalized sweat glands all over the body. And it also does blood vessels. What it does, it originates in the lateral horn of the spinal nerve. You'll remember the spinal nerve kind of looks, or the spinal cord kind of looks like this. Vertebra, okay. We'll have nerves coming out, coming together, like this. So these autonomic nervous systems, they're going to originate from the lateral horn of this is the gray matter. So when they come out, they'll come out and they will go to the sympathetic chain ganglion. And if it goes up into the thoracic cavity, so that's going to be your heart or your lungs, it's going to be a sympathetic neuron. And this is from T, let's see here, T1 to T5, T6 down to T to L2 is going to be parasympathetic. So it will innervate the thoracic cavity, the lungs and the heart, the T6 and the L2, it's going to be called the splanchnic neuron, and it's going to bypass the sympathetic chain ganglion, and it's actually going to synapse in the collateral ganglion, and then it will go to anything in the abdominal pelvic cavity. There's also another relay for parasympathetic or for sympathetic. It comes down, sorry, this is getting crowded, it comes down, we'll draw it down here, and it goes all the way down to it goes through the chain ganglia all the way down to the adrenal medulla. The adrenal medulla will then release epinephrine, which will go throughout the blood into the body. It'll affect the heart, increase the heart rate. So it's the sympathetic, parasympathetic. So the parasympathetic is going to go in the brainstem, and it's just going to come out. It's not going to go down the spinal cord at all. It's going to be the vagus nerve here. It's going to be most of it. You also have some down here in your sacral division. So you'll have sacral 1, sacral 2, and you'll have some innervation from the sacral division as well. About 80% from up here in the vagus, and about 20% down here in the sacral division. And these are going to go down, and they're going to innervate at what's called a I believe it is a peripheral ganglion, terminal ganglia. So this is going to be a terminal ganglia. Which is going to be right adjacent to the target or the effector organ. So it's going to synapse here, and then you're going to have an effector organ close by your heart, your lungs, stomach, anything like that. Like I said, with the parasympathetic, that's going to be more of a rest and digest actions on the body. With all of these, both the sympathetic and the parasympathetic, there's two neurons. So you have your presynaptic or preganglionic neuron, and then when it synapses in the ganglia, and then it starts into your postsynaptic neuron. So there's two neurons for each, the sympathetic and the parasympathetic division. These both use a little bit different neurotransmitters, and I can draw these up on the board really quick. The sympathetic. We'll draw three. So here we have, this is our preganglionic neuron. It comes over here into the sympathetic chain ganglia. We're going to synapse. It's going to release acetylcholine. So acetylcholine. This is going to be an N2 receptor. It's going to come out here, and then we're going to release norepinephrine, and that's going to bind to draw a bunch of them up here. These are called adrenergics. We'll go alpha 1, alpha 2, beta 1, beta 2, beta 3. These are adrenergic receptors. Adrenergic receptors are going to bind norepinephrine, epinephrine, dopamine, catecholamines. They're going to bind catecholamines. So those are our adrenergic receptor. This is what you're going to see a majority of the time. This is going to be your sympathetic pathway. There are some exceptions, but here, once again, we're coming here, we'll have our neurotransmitter. This is acetylcholine once again. An N2 receptor, and this receptor is going to go to generalized sweat glands. These are going to be an M3 receptor. M stands for muscarinic. It's going to be acetylcholine, again, the neurotransmitter, muscarinic receptor. That's going to be for sweat glands. The last one of the sympathetic chain is also kind of a rare, I guess there's really only one pathway for it. It's going to go all the way. This is the adrenal medullal pathway. We're going to do the same thing. We're going to have acetylcholine going to come over here. The adrenal medulla is going to have an N2 receptor on it. It's going to release epinephrine in your blood, and epinephrine in the blood. The blood will carry the epinephrine, and it can go and it can act on anything that is an adrenergic receptor. So epinephrine, you'll see like an increased heart rate. You'll see bronchodilation in the lungs. You'll see, let's see what else is adrenergic receptor. You can see restriction of vessels, blood vessels. So that's basic. Your sympathetic, your parasympathetic is easy just because it's one, so we'll just say the parasympathetic here. Okay, so it's the same. We're going to start preganglionic. Remember, this is in the vagus nerve or the sacral division. It's called cranial sacral because it originates in the cranium or the sacrum. So we can come over here. We're going to have again acetylcholine. We're going to have an N2 nicotinic 2 receptor. And we're going to go out here. Acetylcholine once again. You see, acetylcholine is important in this nervous system. ACH, and then we're going to have the different receptors. We're going to have muscarinic receptors, M1, M2, M3, M4, and M5. And depending on what the receptor does will determine if it's going to cause an excitatory postsynaptic potential or an inhibitory postsynaptic potential. So I could kind of go over that. We'll go over maybe a little bit more about these receptor types really quick. Alright, so receptor types. I told you before we had the adrenergic, so ADR, adrenergic receptors, and then we had the cholinergic receptors. Adrenergic, that's going to be our catecholamines. We are going to bind to catecholamines, catecholamines, and that's going to be our epinephrine, norepinephrine, our gabapentin, not gabapentin, yeah, glutamate. Those are going to be our catecholamines. Cholinergic receptors, these are going to be, we can say that there are two divisions of these. Let's just do that. We'll say muscarinic, and muscarinic and nicotinic. Nicotinic, there's an N1 and an N2. The N1 is found in skeletal muscle, and the N2 is found in the autonomic nervous system. Muscarinic, so there's M1 through M5. Just different receptors found in the autonomic nervous system. Each of these kind of does a different thing. They're all going to be G protein. They're all going to be metabotropic. Ionotropic is when you have something that opens. Nicotinic. These ones will be ionotropic. They're going to open a transport protein that's going to allow the flow of ions into either the muscle or the axon that's going to propagate an action potential. These are ionotropic. The muscarinic and the adrenergic receptors, they are all metabotropic. These are all G protein. So they'll bind, and then within the cell they'll have different parts that not dissolve, not dismember, but they kind of go and do their own thing. They kind of take the message to different parts of the cell, and that causes an overall effect that they want. Metabotropic and adrenergic. So there's two pathways that we've learned about so far with these. So there's the cyclic AMP pathway. There's also the IP3 and calcium pathway. So we can look at these and we'll remember that one will cause a couple will cause an increase in CAMP, a couple will cause a decrease in CAMP, and a couple will cause an increase in IP3 and calcium. So the ones that cause an increase in cyclic AMP is going to be our beta receptors. So beta 1, beta 2, beta 2, beta 3. For cyclic AMP, for decrease in cyclic AMP, we can remember that that's going to be our even receptor. So it's going to be our alpha 2, our muscarinic 2, muscarinic 4. For RP3 is going to be our odds that are left. So we're going to have a alpha 1, M1, muscarinic 1, muscarinic 3, and a muscarinic 5. And those are going to be our IP3 calcium receptors. That's what they utilize. Let's see here, what else do we need to talk about? Neurotransmitters, types of receptors and actions discussed. Cholinergic and adrenergic receptors. Explain the different subdivisions of each type. Okay, give mechanical actions of each type of receptor. What happens when the nerve binds to the receptor? Okay, so we'll give just some quick relations to in the body. So let's go with your eyes. And your eyes, we'll do your heart, we'll do your lungs, we'll do blood vessels, we'll do sweat glands. What else can we do? We can do your skin. We'll call this skin. This would be like your rectificular muscle. So your eye. We know that the eye has an alpha 1 receptor on it. It also has a muscarinic 3 receptor on it. The alpha 1, if we remember, those are going to be our adrenergic receptors. Adrenergic receptors are going to be in the sympathetic division. And then over here we'll have our parasympathetic. Okay, so if we have a catecholamine that's going in the blood that gets to our eye, or if we administer a catecholamine, a topical catecholamine, or an alpha 1 agonist, we are going to have dilation of the eye. Similarly, if we if we have a stimulus that is parasympathetic in nature, it comes and it binds to the muscarinic 3, we are going to have a constriction of the pupil in the eye. And it's possible to do these at the same time as what happens when you go to an eye doctor. They'll put in an alpha 1 agonist that will dilate the eye, and then if they put an M3 antagonist, that will also dilate the eye even a little bit further because it's inhibiting any constriction that's happening. The heart we know it has a beta 1 receptor on it. It also has a muscarinic 2 receptor on it. The lungs, I'll just finish this out really quick. Lungs have a beta 2, muscarinic 1. Blood vessels have an alpha 1, and remember, blood vessels are out in the peripheral nervous system, so they have to go through the motor neurons. No parasympathetic is going to go through the motor nerves. Spinal nerves, sorry, they're not going to go through the spinal nerves. Just the sympathetic side. So the alpha 1 for that. For the sweat glands, it's going to be the muscarinic 3. For the skin, we're going to go back to the alpha 1. So with the heart, if we have a beta 1 receptor, and remember, I think I told you this rule. If not, I'll tell it to you now. So based on whether these are labeled even or odd, we can think of even receptors as inhibitory, or and these positive receptors are going to be something that's excitatory. So we think of a beta-1 receptor. If we stimulate this beta-1 receptor with a catecholamine in the heart, we can predict that we're going to have an increase in heart rate and an increase in force of contraction. If we have an increase in a muscarinic, or if we have an increase in acetylcholine in the heart, it'll bind to this muscarinic 2 receptor, and it's going to cause just the opposite effect. So we're going to have a decrease in the heart rate and a decrease in force of contraction. Similar in the lungs, we'll talk about bronchodilation. So people with asthma, that's where their bronchioles are constricted down, they can't get enough air in. Same with people with obstructive diseases, COPD. They will need a medication called albuterol, and albuterol is a beta-2 agonist. So if you give them a beta-2 agonist, we can open up, so we'll call this bronchodilate. The tubes going down to the lung. Same with an M1, if we give that, we are going to constrict those bronchioles. Blood vessels, they don't have parasympathetic division, so the only way to really regulate this, we'll have just to limit our sympathetic response. So these are going to be an alpha-1, so if you have epinephrine, norepinephrine especially likes this alpha-1 receptor. Epinephrine really likes the beta-2 receptor. So if you have alpha-1 going out there, it's going to constrict. It can cause the smooth muscles in the arteries or in the venules to constrict. It's going to increase your blood pressure. Like I said, a way to decrease this, if you haven't, let's see here, if you just kind of downregulate the sympathetic nervous system, that's what's going to really take care of this. This sweat glands, that's a muscarinic 3, it's still a sympathetic nervous division. That's going to be activated with acetylcholine. So when that gets to the muscarinic 3 receptor, you're going to have sweating, generalized sweating. There are areas, locations of localized sweating. These are like your armpits, the palms of your hands, in your like near your genitalia. That's when you're going to have an alpha-1 receptor, and that will cause sweating in those areas. The last one we'll talk about is the skin. That's the erector papillae muscle. When you're cold outside, or when you're cold in general, you'll get goosebumps, and that's when catecholamines bind to this alpha-1 receptor, and this will cause goosebumps. We'll just say goosebumps down here. Okay, I think that's all that we're going to talk about. Sympathetic division Yep, I think that's all that we need to cover this time, so